Hello. Sorry I'm not here today, but I feel like I'm still here with you. So, today is all about some algebra, just solving equations, and we have a system here. The first equation here represents an ellipse. I know that because I have x squareds and y squareds that are the same sign but with different coefficients. So that would be an ellipse, and my second one here is a line. It's linear because there's no x squared or y squared. So I know I might have possibly up to two solutions to this system of equations. Let's go ahead and solve this. I'm going to do this by elimination. Let's take the second equation here and maneuver it so I actually end up with y is equal to negative 2x minus 1. And when I take that and plug it into the first equation, I'm going to get 4x squared plus, and then I have negative 2x minus 1 quantity squared equals 25. Simplify that, 4x squared plus 4x squared. This would be plus 4x and then plus 1 equals 25. That gives me 8x squared plus 4x minus 24 is equal to 0. I'm going to carry this around up here and divide both sides by a 4 to get 2x squared plus x minus 6 is equal to 0. That's going to factor into 2x and x. Looks like 3 and 2 with a plus 3 and minus 2. And nope, that's not right. It's got to be minus 3 plus 2. So I get x is equal to positive 3 halves, or x is equal to negative 2. Positive 3 halves, I have y is equal to negative 2 times 3 halves minus 1 if I take it and plug it into this equation. This gives me y is equal to negative 4. So one of my ordered pairs is 3 halves comma negative 4. The other one, if I go y is equal to negative 2 times negative 2 minus 1, is y is equal to 4 minus 1, which is 3. So my other ordered pair is negative 2 comma 3. So if I put this in set notation, I'm actually going to have a set of two ordered pairs. 3 halves comma negative 4, and then negative 2, 3. Now, it's kind of important you see this as a graph, so I'm going to pause the video for a second while I graph this. You can see I have this option here to enter conics. You do too. So 4 for the x squared. That'd be 0 for xy. Sorry, I had the computer folded back. Then 1 for the y squared. I guess I could just do that. Then nothing for x. Nothing for y, and if I move that over to the left side, that would be a negative 25. So there's my ellipse, and then for my second feet, I will graph y is equal to, oops, I want to go back to my view menu and change my graph entry to just function mode, and then let's do y is equal to negative 2x minus 1. So I haven't tried analyzing the graph to see if I can find an intersection point of these two. Whoa, I can. That is cool. Negative 2, 3. It actually wants a box drawn. Oops. Pick a corner here and a corner down here. And 1.5 comma negative 4. So that confirms it. I have two ordered pairs that match my answer. Awesome. I'll walk you through that more a little bit when I get back. I honestly just learned that now on this video, so this is an exciting time for you. Let's go to the second example. Let's do another one. Let's go x squared minus 9y squared equals 9, and then x plus 6y is equal to 3. Now, feel free to pause this video, work on this by yourself, and check answers. That's kind of like a more efficient way of doing this. But if you're not, if you're following along, I know that this is a hyperbola, and this one is a line. So what I'm going to do is actually graph this hyperbola on the graphing calculator first now, just to check to see how many solutions I'm going to have. So let me go back and start a new graph. Here I am trying to learn this calculator on this thing, this program. I'm going to pause this. Change the view now to match your view. So if I go menu, view, nope, sorry, graph type, and I go to, 3. Go to equation and conic. I can get this general form for any conic, and the one I gave you was 1x squared plus 0xy, and that would be a negative 9y squared. There's no x term, there's no y term, and the constant term moved over to the left side would be a negative 9. So that's a hyperbola, which is what we suspected it would be. Then if I want to graph a line, I guess I could do it in the conic section, but it's probably easiest just to go to graph, entry, edit, and change it to function mode, and to move that into, this would be y is equal to, I could actually just make it parentheses, negative x plus 3 parentheses, and then put over the 6 when you divide that to both sides. So then we get a line, and we can see we have 2 intersection points. I'm going to move this out of the way and move that out of the way. So I have 2 intersection points. Let me just check to make sure you can actually do this. Analyze graph, intersection. Yep, I can draw, it says first corner, so I'm actually trying to draw a box. First corner means the top left of a box I draw, so I'm going to put a point there, and then move this down and put a point, and it found an intersection. That is so awesome. I can do another one here. So those are my answers. Well, negative 5 and 4/3 and 3, 0. So let's go back here and try to get those answers. Let's just do this the other way. Let's take this and set this equal to x. So I have 3 minus 6y. Take the 3 minus 6y, plug it in, and so I have 3 minus 6y, quantity squared, minus 9y squared equals 9. Then I have 9 minus, that'd be 3 times 6 is 18, negative 36y plus 36y squared minus 9y squared is equal to 9. So I get 36 minus 9 is 27. I have 27y squared minus 36y, and the 9's drop out. Pull out a greatest common factor from the left side, and I have 9y, parentheses, and then I have 3y minus 3y minus 4 equals 0. So this gives me y is equal to 0, or y is equal to 4/3. If y is equal to 0, and I plug that in, I get x is equal to 3. And if y is equal to 4/3, I have 3 minus 6 times 4/3, which is 3 minus 8, or negative 5 for x. So my ordered pairs are negative 5, 4/3, and 3, 0. Check my graph real quick, and voila, that does match. So your graphing calculator becomes a way to check. Now, I would have to be nice enough to let you use that not in testing mode during a test, and sorry I can't do that, but this is a way for you to check your homework, and also to learn a little bit more about your graphing calculator. So let's just do one more if you need it. Honestly, if not, you're welcome to go ahead and just freeze and fix and do something else, or start your homework and all that. But let's do x squared minus y squared is equal to 12, and xy is equal to 8. This is an interesting one, because here we clearly have a hyperbola, x squared minus y squared, but here we have something a little bit different. This is actually a hyperbola of a different sort. In some ways, it's a rational function, and so it's not truly a conic section. We'll learn more about these in pre-calc, but it forms a shape somewhat like that. So anyway, I'm going to go to the graphing calculator and graph these two. So let me go home, create a new graph. Let's go to menu, go to graph, entry, edit, go to equation. Let's do a general conic. And my first one is 1x squared plus 0xy minus y squared, so I'm just going to put a negative 1, 0x, 0y, and if I move the 12 over, it becomes a negative 12. enter. I have a hyperbola, exactly what I expected. Next, I'm going to press tab so I can enter a second one. And see, it's already giving me a general conic form. So this is actually 0x squared plus 1xy plus 0y squared plus 0x plus 0y, and then plus, if I move the 8 over, it's negative 8. Enter. You can see we have this sideways, or this sort of slanted, I should say sideways, I should say slanted hyperbola. So it's kind of cool. We have two intersection points we want to worry about. Menu, analyze graph, intersection, first corner, -4, -2 is one of them. Analyze graph, intersection, and 4, 2 is one of them. Alright, let's confirm that. Let's go to here and solve. I have y is equal to 8 over x. Take that and plug it in, and I get x squared minus 8 over x quantity squared equals 12. Or I have x squared minus 64 over x squared is equal to 12. Let's multiply both sides by at least common denominator, and I get x to the 4th minus 64 is equal to 12x squared. Set it equal to 0, x squared minus 12x squared, sorry, x to the 4th minus 12x squared minus 64 equals 0. That's going to factor into x squared and x squared. 64 is 16 and 4, so that's going to be minus 16 plus 4 equals 0. Cool thing about this is the x squared plus 4, that can equal 0, because we're going to solve this over the real numbers, not the complex numbers. And your homework says to find the real solutions. FYI, if we wanted to find the complex solutions, we would just take this and say x squared is equal to -4 and x is equal to plus or minus 2i and go from there. But we're not going to do that right now. We're just going to stick with the real solutions. The real numbers, we have x minus 4 and x plus 4. And we know that x is equal to plus or minus 4. So I'm going to take that and plug that into x, or y is equal to 8 over x. And you should be able to see that when x is 4, y is 2. When x is -4, y is -2. So that gives us the ordered pairs 4, 2, and -4, -2. Oh heck, let's do one more. Number 4. X squared plus 2y squared is equal to 23, and 2x squared minus y squared is equal to 1. I'm going to graph these two. It's new graph. I'm getting fast at this. Graph entry, equation, conic section, general conic section. So 1x squared plus 0xy plus 2y squared plus 0x plus 0y, and then -23. That's the first equation. Boom. Ellipse. Let's go enter a second one. Oh wait, I don't need to do it through here. I just press tab, and then I get an entry. 2x squared, 0xy. I want minus y squared, so I'm going to put -1. 0x, 0y, and -1. Ooh. You can see my point. We have 4 intersection points between an ellipse and a hyperbola. So let's just make sure we can get 4 intersection points. Now, the way these are set up, I can actually use an elimination method on this. That's kind of neat. I can go x squared plus 2y squared is equal to 23. And the bottom one, I can multiply this by a 2, so I get 4x squared minus 2y squared is equal to 2. Add them up, and I have 5x squared is equal to 25, or x squared is equal to 5, or x is equal to plus or minus root 5. Okay, well, now we're going to say if x is equal to root 5, let's plug it back into one of the original ones. Let's just go in the second one. I'd have 2 times 5 minus y squared is equal to 1, or y squared is equal to 9, or y is equal to plus or minus root 3. Now, if x equals root 5, y is equal to plus or minus root 3, if x equals negative root 5, I can also follow the same process and still get y is equal to plus or minus root 3. So this actually gives me the 4 ordered pairs: radical 5, radical 3, radical 5, negative radical 3, negative radical 5, positive radical 3, and negative radical 5, negative radical 3. And I won't do the intersections on here, but that matches. So that's it. Your homework is, I'll flash it up here for a sec so you can not have to look it up. Boom, right there. 1 through 18 all. So all of these. It's going to take a little bit of time, so go ahead and get started. And I'll flash the key up right here, which you should find online, but you can also use in this video. So good luck, enjoy. One thing I should mention, too, since I am apparently completely not completely incompetent, but I'm getting laughs here at that. Go ahead and do your imaginary solutions. So back up here when I said x squared, this can't hold, we could find more solutions for that. There's no reason we can't take them and plug them in and say, well, 2 more solutions would be, if I got 8 over 2i, that would be 4 over I, and multiply by an I over I, and I would get negative 4i. And then 8 over negative 2i would give me 4i. So 2 more solutions for that could have been positive 2i, negative 4i, and negative 2i, positive 4i. So you'll see those in the answer key. I just didn't want to mess you up or confuse you with those. Good luck. Enjoy.